Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3373. Maximize the number of target nodes after connecting trees to. Okay, and yesterday we have solved the part 1 of this problem. Maximize the number of target nodes after connecting trees 1. Okay, so problem statement is also a little bit similar, okay, to today's problem, this one, right? In this problem, if you see, a k value is given, but in today's problem k value is not there, right? So I'm going to write a little bit same code like yesterday's problem, DFS and BFS. I'm going to solve this problem using two approaches as well, using DFS and BFS. Okay, right? So now let's move to the today's problem. All right, so let's read the problem statement first. There exist two undirected trees with n and m nodes labeled from 0 to n minus 1 and 0 to m minus 1 respectively, right? So undirected tree is given to us with n and m nodes, right? And they are labeled from 0 to n minus 1 and 0 to m minus 1. Okay, you are given two 2D integer arrays, edges 1 and edges 2 of length n minus 1 and m minus 1, right? Where edges 1 of I, A to B indicates that there is an edge between nodes A and B in the first tree, and edges 2 of I, U to V indicates that there is an edge between nodes U and V in the second tree, right? Okay, so see this example number 1. So these are the edges given to us, right? So here if I give the indexing 0, 1, 2, 3, okay, so how many total number of edges given to us is 4, right? And here in the problem statement it is given that edges 1 are of length n minus 1. Okay, so here I can write this 4 is nothing but my n minus 1. Okay, and I can calculate the n value as 4 plus 1, that is 5. Okay, so we have how many nodes? We have n nodes, that is 5 nodes, right? So here we have to draw 5 nodes, right? So see number 0, 1, 2, 3 and 4. Okay, so total 5 nodes, and they are labeled from 0 to n minus 1. Okay, so n value is 5, so 5 minus 1, 4. Okay, so 0 to 4, right? Same way here, 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index. Okay, so here the length is m minus 1. Okay, so m minus 1, if you see, it is nothing but total length is 7, right? So m is nothing but 8. Okay, m is 8, so we have nodes labeled from 0 to 7. Okay, 4, 3, 2. Okay, so here you see 0, 1, 2, 3, 4, 5, 6, 7. Okay, we are good, right? So I hope that you guys are clear with the first two lines, right? Now after that, node U is target to node V if the number of edges on the path from U to V, okay, is even, right? Note that a node is always target to itself. Okay, so we have to consider the number of edges on the path from U to V. If it is even, then our node U is the target to node V. Okay, and note that a node is always target to itself because it is going to start from 0 only, right? Node U, right? It is going to start from 0 only, right? Always. So we have to return an array of n integers answer, where answer of I, okay, n, I'm talking about n is nothing but your first tree. Okay, so return an array of n integers answer, where answer of I is the maximum possible number of nodes that are target to node I of the first tree. If you had to connect one node from the first tree to another node in the second tree, note that queries are independent from each other. That is, for every query you will remove the added edge before proceeding to the next query. All right, so now let's understand all this stuff with an example here. Okay, so first here, tree 1. Okay, so in tree 1 these are the edges 0 to 1, 0 to 2 to 3 and 2 to 4. Okay, so we draw this tree, right? 0 to 1, 0 to 2 to 3, 3 to 4, 2 to 4, right? These are edges. Then here in this is tree 2. Okay, so 0 to 1, 0 to, okay, so 0 to 1, 0 to 2, 0 to 3, then 2 to 7. Here see 2 to 7. Okay, then after that 1 to 4, 1 to 4, then 4 to 5, and then 4 to 6. Okay, so this is how we draw this tree, right? So now what we need to do actually in this problem, let's understand that. All right, so first we have to just create one adjacency list. All right, and in that adjacency list I will just write all the neighbors. Okay, so for like here, if you see, if I write for 0, so 0 is connected with 4 3 1, 0 is connected with 1 and 2, right? Same way here, 1 is just connected with 0, right? Here this 2, if you see, 2 is connected with 0 3 and 4. Okay, this is how I am going to create adjacency list, right? 3 is created 3 is connected with just 2, right? And 4 is just connected with 2, right? So this is nothing but my adjacency list. Okay, so this is what we need to create, right? Okay, now once we do all this, then we have to just apply the DFS on this, right? So we have to consider the colors, right? Like even and odds, right? So even distance, then we have to count. Okay, right? So node u is target to node v if the number of edges on the path from u to v is even. Note that a node is always target to itself. Okay, so let's consider this tree 1 only first. Okay, in tree 1, right? So here we are going to start from here, right? So this node is at distance 0 to itself, right? Okay, 0 to itself, right? And let's say I'm going to build colors. Okay, I'm going to count the colors, like how many nodes which are at even distance and how many nodes which are at odd distance, right? So I'm starting from here, right? So this is at 0 distance. Okay, and here see, there is just one edge from 0 to 1. Okay, so this is at just 1 distance. Okay, so let's say color is 1. Okay, 0 means, let's say even. Okay, and 1, let's say odd. Okay, all right, so this is 1 also, right? 0 to 2. Okay, I'm starting from 0 to only one edge is there, right? So this is nothing but odd. Okay, and then here you see 2 to 3. Okay, this is even distance, right? So 0 to 1 edge, 2 to 3, there is one more edge, total 2 edges, that is nothing but even distance. So here I can say this is at 0. Okay, color is 0. I'm writing colors only, 0 1 1, and here this is also color. Okay, so I'm using depth, right? So this is one depth, this is one depth, this is two depth, even depth. So color I'm assigning 0. Okay, that is nothing but even, right? Same way 0 to 4. Okay, so even depth, right? 2, right? So here also I'm going to write 0, right? Even. Okay, so here this is nothing but the colors. Okay, so here if I draw this color 1. Okay, so let's say this is my array color 1. Okay, so here how many nodes we have? A total 5, right? So here 0 index, 1 index, 2 index, 3 index, and 4 index. Okay, so at 0 0 we have color even, right? So for even I'm writing 0 only. For 1 1 odd, for 2 odd. Okay, and same way for 3 it is 0. Okay, and here also it is 0. All right, so this is nothing but color of 1, color of 1. Okay, this is what you need to do, color of 1. You are going to count this, right? And here we have to also count the result. Okay, result, like how many total count of odd nodes and total count of even nodes. All right, so how you are going to do that? That is also very simple. We are just going to implement the DFS, right? So here if you see the count of, in this example, the count of evens is nothing but 3, right? So here I am going to return even count. Even count is nothing but 3 here. In this case 3 zeros are there in total, and total number of odd counts is nothing but 2. Okay, so this is what I'm going to return. Okay, so this is nothing but even count, and this is nothing but our odd count, right? Okay, so this is done, right? All right, so here how you are going to do this, you have to just check the depth, right? So initially depth is going to be 0 for this. So here when we are moving to this children, so we are going to increment the depth by 1. Okay, so here my depth is going to become 1, right? So in that case, in the result I don't need to add anything, right? So this is, let's say this is my result value. Okay, result is just counting the number of evens. Okay, result is nothing but it's counting the number of evens, right? And this is nothing but that you can say n minus res, n minus res. So n value is total number of nodes 5, and result is even. So 5 minus 3 if you do, you will get the odd counts, right? So this is nothing but odd counts. Okay, so in the result I'm going to call the DFS. Okay, and my DFS is going to return this value. Okay, this value, and my DFS is also going to update this color array. Okay, 0 1 1 0 0. All right, So this is what we need to do, right? Okay, right. All right, so here initially let's say how you're going to implement DFS. Let me show you. So initially you are going to pass this starting node. Okay, so your node is here. I'm writing node. Okay, so you are going to pass node, then you are going to parent. Okay, so for 0 parent is nothing, right? There's nothing, so you can write -1. Then you are going to pass depth. So initially you are going to start from depth, right? So this is your depth, right? And then here you are just going to create one array list of children's. Okay, so array list of children you are going to create, and here you are going to update the colors. Okay, so this is nothing but for colors. So these are the things that you are going to call for the DFS, right? Okay, so here in this you are going to, how you are going to update the result. Okay, in the result, but you are going to count, you are going to count even, right? So this is even, right? So here you are going to update result as nothing but 1 minus depth. Okay, what is the depth, and here the modulus with 2. Okay, remainder with 2. So 0 modulus with 2, 0 only, so result is going to update 1 here, right? Same way if you apply result here, and here depth was 1, right? So in this case, depth is 1, 1 modulus with 2, remainder is 1, 1 minus 1, 0. Okay, so no impact on the result here. No impact on result here. No impact on the result here. No impact on result here. Okay. Same way, there is the impact from result here. Okay. One result. Okay. So in total, 1 here it is going to remain 1 only. Here also it is 1 only. Here 1 plus 1, 2. And here 1 plus 1, it is going to become 3. Okay. So we will see this in code. Okay. But this is what we need to do, right? So we are going to check the colors of all the nodes, and we are going to count the even and odd. Okay, same way, same thing you have to do for this tree 2 also. Okay, this is your tree 2, right? So we are going to start from 0 only, right? So here this is okay. So let me write the colors in a white color pencil, right? So this is 0. Okay, and then 1 is for odd. Okay, 1 1, and this is 1. Okay, odd. Then this is 0, then this is 0, and then this is 1. Okay, and then this is 1, right? So these are the colors. All right, so here if I draw the same thing for this tree 2 also. So here let's say this is my array, right? And here we have total 8 nodes, right? So here I can say 0 1 2 3 4, and here 5, and here 6, and here 7. Okay, so for 0 color is 0, right? And then 2 3 and 1 it is 1. Okay, 2 3 and 1 it is 1. Then for 4 it's 0, 4 it's 0, 5 it's 1, 6 is 1, and 7 it's 0, right? So these are the colors, right? Color of 2. Okay, so we are just going to write one method. Okay, in that method only, first we are going to do this for tree 1, and then same thing we are going to do for tree 2. Okay, then also in tree 2 also you are going to count the even number counts and odd number counts. Okay, so even number counts, if you see 1 2 3. Okay, so even number count is 3, and total number of nodes is 8, and minus this res. Okay, 3, so that is nothing but 5. So 5 is nothing but odd number of counts, right? So here 5 ones are there, 1 1 1 1 1. Okay, right. Okay, so this is done. So from here what you need to do, so 3 and 5. Okay, this is nothing but your you can say this is nothing but your counts. Okay, you can create one count array, right? This is, let's say, count 2. Okay, count 2. In this you are passing even, and here you are going to pass odd. Okay, and same way, let's say this is count 1, right? Okay, so now here you can connect the tree 1 any node with the node from tree 2, right? This is what you need to do, right? Okay, we can connect. So this we can connect with this. Okay, we can connect with this. Okay, we have choice, right? Okay, so now here what we need to do, right? Let's see. Okay, you have to update the result for this n. Okay, so here see, return an array of n integers answer, where answer is the maximum possible number of nodes that are target to node I of first tree. If you had to connect one node from the first tree to the another. Okay, so for first tree we have to return the answer. Okay, so create one result array. So let's use this pencil, red color. Okay, this is your result array, and same number of nodes are 5. Okay, so this is your result array. Okay, so here 0, this is 1 2, okay, 3, and here this is nothing but a 4, right? Okay, so here see in tree 1, okay, just see tree 1, okay. So in tree 1, if I just want to calculate the answer, okay, result, so I see 40, I'm saying this is one valid, then this is at odd distance, this is at odd distance, this is at even distance, okay. Total 3 are there invalid, okay. So 3 are valid. So here that simply means that for here, if you see, color of 1 is 0, and for this 0, just calculate the count, okay. 0, and here you will get the count, okay, zeros count, okay. So this is 0 count and this is odd count, okay. This is 0 count, this is odd count, okay. So for tree 1, 0 at node 0 is even, okay. So how many total result we are going to get? We are going to get total 3, right? So 3, from here it is going to come as 3, and in this 3, from this tree, okay, from this tree too, so you are going to get, you are seeing here even or odd, okay. So you have to just take the max value out of them, okay. So max value among this 3 and 5 is nothing but 5. Take that, 3 plus 5 out is 8, okay. So why here I am taking 5, okay, why I am taking 5? So it's our choice now, right? So here this is the node from tree 1, okay. You have choices, okay, you have choices to connect, okay. So let's say if you start from this node of tree 2, okay, you are going to get total 5 even distances, 5 even distances, let's say, okay. Here 5 even distances, let's say, okay. And here this is another node from tree 2, okay. And if you start from here, you are going to get let's say you can say that it is nothing but 3, okay. That's 3, okay. So 3, this 3, and this is also even, okay. Since we are dealing with even only, right? So take even only, okay. So this is node 1, okay, and this is node 2 of tree 2. And if you start from here now, if you start from here, you don't see any connection yet. If you start from here, you are going to get 3 even distances, okay. And if you can start from node 1, okay, and you are going to get 5 even distances, all right. So now here let's say this is even color, okay. This is even node, okay. This is a node which is at even distance, okay. Let's say 0, right? Then in the next tree, definitely you are not going to start from here, okay, because this is going to be odd, right? So you are going to connect this, and then you are going to connect this even, okay. So you have to ignore this odd now. So it's good if we ignore the node with the lesser count and we take the one with the max count, okay. So then you have to choose this part, okay. Then you have to choose this path, right? Okay. So here same way, if it is odd, let's say, okay, if it is odd, okay, then also let's say you have 2 nodes, okay. So next time, you, since you are only considering even distance, so next time it's good now if you just connect this 5 for first, right? So from this node you are going to get 5, okay. So there are many other nodes after this, okay, nodes after this, okay. Total 5 at even distance. So if you connect like this, from here you are going to get 5, okay. So then we have to take this, all right. But if you connect this directly, then this is going to be at odd distance, okay, and then this will be at even distance, okay. So we have always has choice now from tree 2. So I will always take the max value, whatever the max value, okay. I will make this even, I will make this at even distance, okay. If I want, I can make this at odd distance if I want, okay. I have choice, okay, because I am going to draw one edge and it's my choice, and I can use that edge to node 1 or node 2, okay. But I want to make sure that I will always take the max value among these, okay, so that I will get the max nodes, right? Since we have to return the maximum nodes only, okay, maximum possible number of nodes, okay. So I have choice now which path I want to follow, okay. So that's what. So here from this I will take always max, okay. So 3 plus 5, 8. So here I'm going to update at 8, right? Now here see this brown color pencil, okay, for 1. So for 1, this, and what is at odd distance? Odd distance is, this is 0 is at odd distance, and this 2 is at even distance, okay. So for 1 only 2 is at even distance in tree 1, okay. So 2 nodes, right? So that simply means the count of ones in, so count of ones is 2 here, okay. So 2 plus 5, 7, okay. Then here 2 is odd, odd is 1, okay. 2 plus 5, 7. Then here 3 color is even, 0, so 0 count is 3 plus 5, 8, Okay, and 4 is even is 3 plus 5 8. Okay, so 8 7 7 8 8 8 7 7 8 8, this is your output, that's it. Okay, so this is how we have to solve this problem. Okay, so I'm going to write the same code. Okay, whatever I explained now, first I will use DFS and then I will use BFS. Okay, but approach is going to be same only, whatever I explained here, right? So let's write the code for this now. Okay, so here first of all what you need to do here, just calculate the edges. Okay, n value and m value. Okay, so n value you are going to calculate it edges 1 dot length plus 1, right? So here edges 1, code is going to be very small. Okay, not big, only I think 40 lines maybe. Edges 1 dot length, okay, plus 1, and then m is nothing but edges 2 dot length plus 1, right? This is done. Okay, then create two arrays, color 1 new int, and here you have to pass n, and here int color 2, and here you have to pass new int m. All right, and here you have to count 1. Okay, count 1 is equal to, and here you are just going to call the build method. Okay, so just like yesterday problem, I'm going to call build method, and here edges of 1 I'm going to pass this time, and also I'm going to consider color. Okay, color 1. All right, same way you have to do the same thing for secondary, right? So here again you have to call this build method, and in this you have to pass edges of 2, and here this time just pass color of 2. Okay, so this is done, and then here in the end we have to just return the answer in the result. Okay, so here new int n, right? And then you have to just run one single loop. Okay, int I is equal to 0, I is less than n, I plus plus, and here inside this you have to just update the result at I. Okay, is equal to, so here first check the color of that particular node. Okay, so color 1 of I. Okay, whatever the color, okay, we have to just take the count of this, right? This, for this color, what is the count? Okay, so here inside this you can write count 1. Okay, count 1 color 1 plus I, and from the secondary you have to just take the max of even and odd count, right? So here you have to write math dot max of count 2 comma 0, and here count 2 comma 1, right? So here this is how you have to modify your result, and in the end you have to just return the result. Okay, so this is the base of this problem, and it is going to be same for both BFS and DFS approach, right? So now first let's write the build method now. Okay, after this, so here private int, and here you have to write build, and here you have to pass the edges. Okay, so edges, and here you have to pass the color. Okay, color, done. Now here inside this just calculate the length of the edges. Okay, so edges dot length, okay, you have just calculate the number of nodes. Okay, edges dot length plus 1, right, and value. Now here create one array list children. Okay, so list, and here integer, we did the same thing in yesterday problem also, children, and here new array list. All right, this is done, and now after this you have to write here you have to write for int I is equal to 0, and here you have to write I less than n, and here you have to write I plus plus. Okay, and then here you have to write children dot add, and here new array list. Okay, so for all these I'm just going to create one array list, empty array list, and now I'm creating the adjacency list here, right? So now I have to fill the values. So here I'm going to iterate over all the edge one by one. Okay, so here edge, okay, you can use for each loop edges. So here inside this you have to write children dot get, and here edge 0. Okay, and here dot add, and here you have to write h1, okay, and here just like this, right? Done. Okay, now copy this, and now after that just paste it here, and here you can write edge of 1, okay, dot add edge of 0. All right, so this is done. Okay, now after that here you have to update the result, okay, int result is equal to, and here you have to call the DFS method, okay. So result is going to count, this result is going to count the even number of nodes, okay, nodes at even distance. Okay, so here you are going to call DFS method, okay, DFS, and in this DFS you have to pass the node, the parent, okay. So right now for node 0 parent is nothing but 1 minus 1, okay, no parent is there, right? So here, then after that you have to pass the depth, okay, so 0, and then here you have to add this array list, okay, just copy this, add this, and then after this here you have to pass the colors, right? So here just copy this and pass this, okay. So this is done, right? Here why I'm writing it like this, here it's not required here, but here we have to just pass the color and we have to pass the children, okay, like this, right? So let me remove this, done. All right, so this is how I'm going to call this DFS method, right? And from here from this build I'm just going to return what even count and odd count, okay. So new int, and here my array is going to consist of two values, one is even count res and odd count n minus res, that's it, okay. Now here let's define this DFS, okay. So DFS only very small code, okay. So here also you have to write private int DFS, okay. Now write everything whatever explained here, okay. So first you are going to pass node, okay, then you are going to pass parent, okay, and then you are going to pass the depth, okay, and now you have to copy this, okay, in the method this, okay, and then here you have to pass this color, all right, copy this and paste it here, all right. So this is done. Now inside this what you need to do, okay. So inside this here you have to just update the result, okay. So result, so here simple now, 1 minus, and here if depth is a odd, okay, if depth is even, so you are always going to get the remainder as 0 only, okay, depth modulus with 2, right? So we are going to get the 1 in the result, okay. But if it is odd, then we are going to get the result as 0, because 1 modulus with 2 is 1, 1 minus 1 0, okay. And here how we are going to fill the color, okay, color, and add this particular node, okay. So simple now, depth modulus with 2, that is going to give me the color of this particular node, okay. Copy this, paste it here, all right. So this is going to fill the color, right? Now here we have to just iterate over all the child of this okay node. So here children dot get, okay, and here you have to just pass the node, and now inside this just check if child is equal to parent, okay. Then in that case you don't have to check now, right, because we have already pasted that simple means. So here in that case just write continue, okay. Here this C is capital, okay, this is capital, right? So let's fix this, right? Okay, so this is done, okay. And then after that here you have to just update the result as result plus equal to, and next time again call the DFS, okay, this method for the children's, okay. So here just call this, and this time our node is going to be become child, okay, parent is going to be the current node, right? And then depth, in this case we have to increment it by 1, okay, depth plus 1, okay. And then children color we are going to pass, and here in the end just return res value, okay. That's it, okay. So see, only, okay, less than 40 lines, right? Okay, so now let's run the code and see if any code issue. Will try to fix that. So yes, there are some issues, so let's fix that. So we are getting issue here, okay, the semicolon is missing. Let's add this, let's run it again. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? Okay, so I hope that you guys are clear with this DFS approach, okay. Now I'm going to make the some changes in this code only, right? And I'm going to implement BFS, all right. So here for BFS we don't need this method, okay. I'm going to delete this, Okay, and here instead of DFS I'm going to call BFS. Okay, so here just do one thing here. In this code you have to just simply return here, just write BFS. Okay, everything else will remain same. Okay, BFS, and here you have to just pass the starting. Okay, start, you are going to start from 0 node, right? And then you have to just pass this children. Okay, these are the essential list that you have created. Okay, and then you have to just pass the color. That's it. Okay, that's it. And now we are just going to implement the BFS code. Okay, this is done, and this is what we need to return. And here let's come now and write the code for this, right? Okay, so here private int, here you have to write BFS, and now here you have to pass int start. Okay, and here why I'm writing again. Okay, let me just copy this here, right? Okay, and here you have to write just like this now, color, and here read this. Okay, so in BFS we are passing children and color. Okay, so clear, right? And now here let's write the code for this, right? So we have to take the queue first, right? Okay, so in queue what you need to do, pass the array. Okay, int array, and here queue is equal to new linked list. All right, so once this is done, then we have to keep track of the visited nodes also. So here you have to write boolean visited array. Okay, boolean visited is equal to new boolean, and here you have to just pass the color dot length. Okay, color dot length. This is done, and then after that you have to keep track of the even count and odd count. Okay, int even count start from 0, right? And here odd, and here you have to write count. Okay, odd count, and here just set it to 0. Okay, and then after this what you need to do, just in the queue offer the starting position. Okay, queue dot offer new int. Okay, and you are going to pass what, you are going to pass the start. Okay, the node, and the current depth is 0 for this. Okay, so this is what you have to pass in queue, and here just mark this first node as visited. Okay, so visited of start, you have to pass visited of this node 0. That simply means it's equal to true. Okay, this is done. Now here simple one while loop you have to execute. Okay, same code for BFS. Okay, queue is not empty. Okay, until then you have to execute this. All right, so here inside this first poll. Okay, so cur int cur is equal to queue dot poll. All right, and then take the node at current of 1 or current of 0, cur of 0, right? And then depth at cur of 1, depth at cur is equal to 1. Okay, then once this is done, then after that update the color of node. Okay, color of node is equal to depth modulus with 2, right? And then here just check if depth modulus with the 2, okay, if it is equal to 0, right? So in that case we have to increment the even count. Okay, even count plus plus, and in the else part we have to increment the odd count, right? Else here we have to increment the odd count, right? Odd count plus plus, right? This is done here. All right, so this is done. Now simple one for loop. Okay, we have to visit all the neighbors. So int neighbor. Okay, and here you have to write children dot get node. Okay, so we have to visit all the children's. All right, and here inside this, if we haven't visited that neighbor, okay, if we haven't visited that neighbor, all right, and then in that case just mark visit this neighbor. Okay, visited this neighbor to true. Okay, to true, right? And then after that in the queue just offer this. Okay, queue dot offer new int, and here you have to pass neighbor, and then here you have to pass depth plus 1. Okay, this is done. All right, and then here after this you have to simply return new int.
and here you can simply write even count and odd count. That's it, even count, and here odd count. All right, I think that's it. Let's run the code and see if there are any code issues. We'll try to fix that. So see, all the test cases has been accepted, right? Okay, so let's submit the code. So see, our solution is accepted, right? So I hope that you guys are able to understand both the approaches, DFS and BFS. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.